Glad you can join me on this lesson as we'll be solving a question in mathematics on geometric progression. So let's take a look at the question. In a geometric progression, the second term is 21 and the fourth term is 189. Calculate the A, first term, and the common ratio, B, the sixth term, C, sum of the first 5 terms of the progression. So let's first start by finding the first term and the common ratio. So when you are given a question like this, you're only given two terms. You have given the second term and the fourth term. What you have to know is that you have to find, or you have to come up with the two equations. So let's write our formula for the nth term. Tn equals ARN minus 1. Where we have Tn there, let's replace with the second term, which is 21, equals, where there's A, we don't have A, R, we don't have R, but N there, where we are finding the second term here. So 21 is the second term. So where there's N, you have it as 2 minus 1. And then we can rewrite 21 equals AR. 2 minus 1, it is just 1. So this is our first equation. Let's formulate the other equation using the fourth term. You can write Tn again, AR to the power n minus 1. So we are using the fourth term, so where there is Tn, we can replace with 189 equals AR. Where there's n, we put 4 since we are using the fourth term. And then we can write 189 equals AR. 4 minus 1, it is just 3. So this is our second equation there. So the next step is to divide. So we get the first equation, we divide it into the second equation. So dividing equation 1 into 2. So the second equation is 189 equals AR to the power 3, then divide by the first equation, which is 21 on this side, and then on the other side we can write AR. So you have RA and A can cancel out. R into R to the power 3, you just have R squared there. And then 189 divided by 21, it will give you 9. What we are looking for, it is just R, not R squared. So we introduce a square root on both sides of the equation. So the power 2 and the square root will cancel out so that we remain with R. What's the square root of 9? It is 3 there. So now we have our common ratio. We can use this common ratio to find the first term. So let's pick one of the equations. Any of them you can use, but I'll go with the first one, where you have 21 equals A, and then where there's R, I will replace with 3. So you have 3A equal to 21. We divide throughout by 3, 3 into 3, so these will cancel out. You remain with just A, And then 21 divided by 3, it will give you 7. So our first term is 7. Our common ratio is 3. We can go to the second part of the question, which is finding the 60th term. We write our formula for the nth term, AR n minus 1. We are finding the 60th term. So where there's n, we will replace with the 6. T, where there's n, 6, equals, where there's a we said it's 7. And then where there's r there, r it is 3. A, we write 6 again, minus 1. So you have 7. Let's work out what we have in the brackets first. The powers, starting with the powers. So you have 3. 6 minus 1, it is 5. And then, what is 3 to the power 5? So you have 7 multiplied by 3 to the power 5, it will give you 243. 7 multiplied by 243, it will give us 1701. So this is our 60th term. We are done with that. Now let's go to the last part of the question, which is C. So the last part is asking us to find the sum of the first 5 terms of the progression. The first thing to note is that when finding the sum of a geometric progression, when the common ratio, the modulus of the common ratio is greater than 1, your sum of the progression is given by the formula Sn is equal to A 1 minus R to the power n over 1 minus R. But when the modulus of R, the modulus of the common ratio, is less than 1, sorry, here, when the modulus of R is less than 1, your sum of the progression will be given by Sn is equal to A 1 minus R to the power n over 1 minus R. But when the modulus of R is greater than 1, our sum will be given by Sn is equal to A R to the power n minus 1 over R minus 1. So let's take a look at our common ratio. The common ratio was 3. So the modulus of 3 it is greater than 1. So we are using this second formula in finding the sum of the first 5 terms. So we can replace what we have. Where there's n, we replace with 5. A, it is given by 7. The value for R there, it is 3. And then we said n, it's 5. And then minus 1. Divide by R, it is given by 3. And then minus 1. 7. 3 to the power 5, this is 243 minus 1 over 3 minus 1, it will give us 2 equals, so you have 7. 243 minus 1, it will give us 242 over 2. So if we multiply, when we multiply 7 by 243, it will give us, let's multiply, there it will give us 1600 94 divided by 2. So we divide. So the sum of the first 6 terms will be 843. So this is the sum of the first 5 terms. First 5 terms. So we have the sum there of the first 5 terms. We have come to the end of the question. We have come to the end of the lesson. I hope you subscribe to my YouTube channel, and I hope you enjoyed the lesson, and join me in the next video.